Hello friends, welcome to our channel Knowledge Amplifier. So today in this particular video, I am going to discuss how we can execute multiple stored procedures in parallel manner in our Snowflake Cloud Data Warehouse platform. Okay, so previously also I explained this particular concept with Python-Snowflake connection. But this time we are going to use only Snowflake SQL queries and SQL based architecture to run multiple stored procedures in parallel manner. Okay, and for this particular process we are going to use the feature of Snowflake task. So you should have a clear idea on Snowflake tasks tree, etc., which I already covered in my previous video. If you want to know those detailed explanation, you can check the link given in the description box as prerequisites. Okay, so without any further delay, let's try to understand how we can execute multiple stored procedures in parallel. So the approach is very simple and this picture explains the process. What we will do, we will first create a parent task. Okay, and that parent task can be a very simple dummy task like create or replace task, and then you provide the task name, you provide the warehouse where the task will run, and then you can give some schedule interval as select current date or current timestamp, whatever. Okay, that means that will just do a dummy activity, maybe current date it will select or current timestamp, etc. And we are not actually achieving anything using our parent task, but rather this task we are trying to start just to execute multiple childs in parallel. Okay, because in task tree, if we build this kind of architecture and we can set up a dependency that first the parent task will be scheduled, and if parent task is triggered, once it is successful, then automatically all the child tasks will start in parallel manner, whatever is directly connected with that parent, right? So that particular feature we are going to use. What we will do? We will basically create a very simple dummy parent task, and then dynamically, suppose I have to execute 10 stored procedures parallelly, we will create 10 child tasks under the same parent. Okay. So as soon as this parent task will be executed, then automatically this child task will be triggered parallelly, and as they are on same level, so for all of them the start time will be same, ideally same, right? That's how the Snowflake task in a particular level works. Okay, and we have to make sure one more thing in this particular architecture, that is, suppose this parent task schedule interval you have given 1 minute or something, then once the parent task is executed and all the child tasks triggered, it should not happen that the parent task is again triggered after the schedule interval. Okay, because this one we are just creating a dummy step so that basically all other child tasks can run parallelly. If it is triggered second time, then second time also it will run all the child tasks. That will be a problem for us. So we need to build the architecture such that this particular setup, that is parent task, and then multiple child tasks will be created. This architecture will be created, and then parent task we will be basically resuming from suspended state, and obviously child task also has to be resumed beforehand. And then once for the first time the parent task is executed successfully, we need to suspend the parent task, so that next time when the again schedule interval will be over, Snowflake should not trigger the parent task again, because we just want to execute only once all the Snowflake stored procedures parallelly, right? That's the approach what we are going to do. Okay, so let's try to understand about this particular technique, that how we can trigger a task only once and then we can suspend that. Because if we able to crack that particular technique, then building this particular framework will be very simple, a piece of cake. Okay, which also I will be sharing that later point of time. So as of now, let's focus on the parent task creation and making some architecture which will just execute a task only once and then it will suspend the task. Okay, so here what I will do, I will first go to my Snowflake, and then here I will execute some queries. Okay, try to understand very important queries because these will create the base concept. So first I am dropping a database if it is existing having the name Ramu, and then here I am creating that phrase database, and here I am using that database. So I will execute all these queries one by one, and here all the codes whatever I am going to use in today's discussion, all those will be available in the description box or in the comment section, so that you can take from there and practice. Okay, so now what we are doing here, we are creating a table having the name video demo. Obviously it will be created in the Ramu database in the public schema, because here we are not creating any other schema, and by default whenever we create database there are two schema available. One is information schema which store all the metadata, Another one is basically public schema, right? Where we can keep all our objects, stored procedures, tables, views, external table, whatever we are creating in Snowflake under that database, right? So this particular table will be created in the public schema in RAM database. What we are doing here? Here we are keeping an auto increment ID column, and then name we are keeping a default value demo YouTube, and here basically we are keeping another column having the timestamp data type, and that column name is create date. Okay, so here I have executed that. Now here what we are doing, we are basically creating a simple stored procedure. What it is doing, it is executing an insert query in our video demo table which just now we created. Okay, insert into video demo, we are just entering create date. Okay, and in create date here we are passing the current timestamp. So whenever we will execute this stored procedure, always there will be one new entry in the video demo table, as simple as that. So here what I will do, I will run this one. Okay, so demo executor successfully created. Now what I am doing here, I am setting up one variable having the name my variable. Why it is required I will explain later, just bear with me. And here in this variable I am assigning the current timestamp. Okay, so here I will run that. Even if you want to check what is the value stored in that variable, you can do select $my variable, and I will run this one, which is basically this particular value. I can save this one for later usage. Okay, right? So this is what is stored in our my variable. Now what we want to do, whatever stored procedure we have created, a single stored procedure that I want to execute using task. So for that, here I have created a very simple task. Create or replace task. Insert data set 1, 2, 3, 4, 5, 6, 7, 8, 9. Some dummy name I have given. Warehouse name I have provided. I want to run this particular stored procedure with each 1 minute interval. So I have given schedule 1 minute as all demo executor. Demo executor is nothing but our this particular stored procedure name, right? So here what I will do, I will execute this particular task query, right? Now obviously if I do show task, it will be in suspended state. So here you can see if I am doing show task, so it is currently in suspended state. Whenever we create task, by default it is in suspended state. We have to resume that task, right? So here if I do select start from video demo currently, you will see no data in it. Now what I will do, I will basically resume my task whatever I created, right? So here I have resumed. Right now if I do show task again, here you will see that the task state changed from suspended to started, right? Now if I do select start from video demo, currently I will be having no data. Why? Because the task just now started, and after 1 minute it will run for the first time and make an entry. So if you want to get all the details about task and history, then there is a beautiful query which you can execute, and that is select start from table information schema.task history, where you can provide your schema name and the name of your task. Okay, so if I execute this particular query, here I will get the information about my task from the information schema, okay, which store all the metadata. So currently some important points you have to notice in this particular result set. The query ID is null. Why it is null? Because our task even have not executed at least once, right? So it is having no query ID with non-null value. That is point number 1. Okay, as soon as the task will be executed, then we will be getting non-null query ID. Okay, right? And then here database name, schema name. Okay, what is the text, what the task is executing, that we can see here. And then here another important point, schedule time, when the task is scheduled. Okay, similarly here you can see a column next schedule time. So see, the schedule time is 10:07 p.m. okay, and here you can see it is 10:08 p.m. okay. So next schedule and schedule time has difference of 1 minute because we have scheduled our task with 1 minute interval. And another point is query start time is null. Okay, because the task even has not started execution of the query, right? Because the task itself has not executed at least once, because just now we started and 1 minute is not over. So query start time we are getting null. So schedule time, query time, and query ID, these are important columns which we are going to use later point of time. So let's see what is this step. If I do select start from video demo, currently we are having no data because 1 minute is not yet over. And if I execute even the task history, here we are getting query ID null. Okay, right? Let's wait for some time and let's see once the task is executed for the first time. Okay, so when the task is not even executed at least once, if you execute this kind of query, you can note some important point like query ID will be null, query start time will be null, obviously, because query is not even started, and schedule time here you will be getting. Point to be noted, this schedule time always will be greater than whatever we have stored in our my variable, because my variable we have created before creating this task. Okay, so obviously this schedule time for the task will be greater than my variable. See, my variable is stored in 10:05 p.m. and it is 10:07 p.m. So my variable will be useful at a point of time. I will explain that. So here let's execute once more and see here the task is executed for the first time. Now what I can do, I can execute select start from table, same query again. Okay, and see the beauty now what happened. See here we are getting a non-null query ID for this particular task because it is executed once. Okay, if I move to the right, here you will see that query start time also we are getting a non-null value, right? So that is indicating that our start has executed at least once. Okay, and here for the next time when it is scheduled, after 1 minute again it will run. For that, this particular new row is created which is having query start time is null and schedule time it is showing the next schedule time. Okay, right? And here for this one query ID again I am getting null. So for this particular row when the task is executed, then query ID will be again non-null there. What I will do, I will suspend this particular task for the time being to show you one activity. So here I have suspended the task, and here if I execute this particular query again, select start from table, this one, here currently we will be getting only one row because we have given opportunity to execute only once for our task. Okay, our task was executed only once, so only one row we are getting. One more row which we were seeing earlier, which was showing the next runtime, that is gone because we have suspended our task, right? So at the next schedule time, whatever it was showing earlier, that time it will not run, so it will not keep that particular data in information schema. As simple as that. Okay, now recall our problem statement. Here in this architecture, the main funda is we have to execute our parent task only once, and once that is executed, we need to suspend our parent task. So how we can do that? Let us try to understand from the task history. Okay, so one thing you understood that initially whenever we start our parent task, then here in information schema, if we are executing this kind of query, we will be getting query ID null. Okay, and as soon as we will be getting query ID non-null value, that means it is executed at least once, and then and there we have to stop that particular task. That way we can ensure our task is executed only once. Okay, so obviously internally we need to apply somehow a polling mechanism which will poll to check whether query ID non-null value we are getting or not. That I will come later point of time. As of now, focus on this particular code, what it is doing. Okay, select start from table, information schema dot task history, the same like earlier, schema name and task name also I am providing, and query start time is not null. Okay, so here I am reducing the search area in the information schema. What I am saying that you just search where query start time is not null for this particular task. Okay, so if the task is not even executed at least once, okay, obviously you will be getting all the rows which is having query ID null. So only if the task is executed at least once, then only you will be getting query start time as non-null value, right? That is one filter what we are applying. And schedule time greater than my variable whatever I have started. Okay, because we are not bothered about those history which is existing before the task is created. Okay, because my variable is a variable which is storing the timestamp just before the task is created. Here you can see, here we have created the task and my variable is storing just before that what is the timestamp. Okay, so here in this particular select query we are just reducing the search area. We are saying just extract those rows for this particular task from the information schema where query start time is not null and schedule time is greater than the time what is stored in my variable, and my variable is storing the timestamp which is just before our task was created. Okay, so we are not bothered about the past data, what happened before the task was created. We are not at all bothered, right? So I am giving this particular condition. It might happen with the same task name, someone has created the task earlier, so those records this particular time based condition will filter. Okay, and then here we are ordering based on schedule time. That is also fine because schedule time is basically indicating when our task will run, right? So it is perfectly fine to order based on that, and here we are just taking only one row, right? So this particular query let us execute. And what this will give me? This will give me the data if the task is executed. Like in our case, the task was executed at least once, right? So here we are getting some data because all the conditions are satisfied. Because here you can see query start time is not null because the task was started at least once, and then schedule time is greater than my variable. That is also satisfying because schedule time is nothing but after the task is created, and my variable is storing the timestamp before the task was created. Okay, and here we did order by, and here we are taking this data. So this particular query plays a major role. So what we can do, once we resume our task, we can poll our information schema with this particular query, and we can check whether this query is giving some result or not. Okay, if this particular query result said we are getting query ID null, that means the task even has not executed at least once. But if we are getting non-null value, that means the task is executed once and we will suspend that task then and there. Okay, that's the critical point. So basically instead of select star, I can do queries of query ID and then empty data. So as soon as we will resume our task, we need to poll this particular query intelligently to make sure that as soon as we will be getting some query ID apart from this empty string, we need to suspend that particular task. Okay, that way that particular task will be executed only once. Okay, so that's what I am going to do here. But before that, one more thing we need to understand: how should we poll? What should be the poll interval? That is also playing a major role, right? So here you can see our parent task, whatever you have started, that is basically scheduled with 1 minute interval. 1 minute means 60 seconds, right? So here what we need to do, we need to make sure the task is executed at least once. So once we resume our task, it will be executed after 60 seconds for the first time. So obviously there is no meaning of polling within 60 seconds, right? We need to poll after 60 seconds only, because first, suppose at time t we are resuming our task. So at t plus 60 seconds, it will be executing for the first time. And next time it will start execution at t plus 120 seconds. Okay. So what we need to do, in between t plus 60 seconds and t plus 120 seconds, we need to suspend our parent task. That is our job, what we have to handle, right? So what we can do, maybe after 90 seconds, why I am taking 90 seconds, I will tell you. After 90 seconds, we can start polling this particular query. We will keep on executing with certain time interval to see whether any data reached in information schema or not. Actually, we can do just after 60 seconds, but you can just give some more time to update the data in information schema, because sometimes information schema might take little time just to update. So we are giving 30 more seconds to update in information schema. So at t plus 60, our first time task will be executed, and at t plus 90, we will start polling this particular query. We will make an infinite while loop that this particular query, until and unless we are getting basically non-null value, we will keep on poll, and maybe poll interval you can keep 10 seconds. So at t plus 90 it will be executed first time, then t plus 100, then t plus 110, and then t plus 120. But we have to simultaneously keep a very careful attention that at t plus 120 exactly the task should be stopped. Otherwise the parent task will be executed again, and all the child stored procedures parallelly will be executed again. So just we need to keep that concept in mind, that this timing part is very important. At t plus 60, our parent task is executed in t plus 20, its next schedule. So in between that we have to stop. So we are just giving some time to information schema for update. So t plus 90 we will start polling, and with each 10 second interval we will poll. Okay, simple. Now what I can do here, already I suspended my task. So currently if I do show task here in this particular database, we are having only one suspended task, which is having the name insert data set 1 2 3 4 5 6 7 8 9. Right now here let me show you the stored procedure, what I am going to use in my next video to create this particular architecture, where this particular parent task we need to trigger only once and then stop it. Okay, so here is the stored procedure. Create or replace stored procedure dummy executor YT123. This is the stored procedure name. Return type is string. Okay, here you will just return dummy data success or failure. Even you can use try, catch, block and improve that is not a problem. And here language we are choosing JavaScript, execute as Polar. Okay, fine, because we want to just call this particular stored procedure, so Polar write is fine. As So first what I am doing here, I have created a function for sleep. Okay, because we need to give some delay. Like here, before starting our polling, we need to wait 90 seconds, because after t plus 90 onwards, we will start our poll in the information schema for this particular query, right? So for that, we need some sleep functionality. Here we have just created a user defined sleep functionality, which is taking the millisecond as input. So suppose you want to wait for 90 seconds, so 90,000 milliseconds you can pass in this particular function. Here we are taking the current date, and here we are waiting until and unless that much 90 seconds or 90,000 millisecond is over. Okay, right? Now here what we are doing, here we are taking the current timestamp, and here we are storing in a variable. Just like in our this particular code, we have stored the timestamp before the task was created in my variable. Similarly, here I am storing that particular timestamp information in vNow. Okay, and then here I am creating a task, create or replace task, multi-thread child 1 2 3 4 5 6 7 8, some dummy name I have given, warehouse, schedule time 1 minute. Okay, as call, and here we are calling the same stored procedure which earlier I have executed. Okay, here I am preparing the statement and executing that. So this will basically create this particular child task. That is the first step. And then here it will resume that task. That is the second step. Okay. Once it is resuming, here we are defining an empty variable query ID equal to a empty string. So this particular variable will store the query ID. In between each time polling, whenever we will get query ID with a null value or non-null value, that will be stored in this variable. Okay. And here we are making a sleep for 90 seconds, which I already told you why we are doing. And here we are keeping an infinite while loop kind of until and unless this particular query ID we are getting non-null value. Okay, and then here we are executing the same query which I discussed earlier, that is queries of query ID and then empty string as query ID from this particular task history table, where schema equal to public, name of the task we have provided as hard-coded value. Even you can make this kind of stuff dynamic by user input, that is fine. And query start time is not null, and schedule time greater than, earlier I used schedule time greater than my variable, now this time I am using schedule time greater than vNow. What is vNow storing? vNow storing the timestamp before the task was created. So that way we are not at all bothering earlier before creating the task what happened. It might happen that some user has created the same task in past, so those will not be impacting in this kind of scenario when we are scheduling based on the timestamp before the task was created. Okay, so here we are doing order by and limit one. So now here what we are doing, here we are preparing the statement and executing that. Okay, and here we are taking the query ID on, because only query ID we are interested, and until and unless we are getting non-null value in query ID, we will keep on execute this particular while loop with sleep time of 10 seconds. Okay, that is at t equal to 90, t equal to 100, t equal to 110, etc, etc. This particular while loop will keep on pulling our information scheme. Okay, as simple as that. And then as soon as we will get non-null query ID, we need to suspend our task so that our parent task will not be executed again. Just consider this task as parent task only, as I am showing. Later I will add all the child task and show you how parallelly these code procedures are executing in my next video. Okay, so here we are suspending that particular task, and here we are returning success. As simple as that. Now here I will run this particular stored procedure. Okay, now what I will do, I will just recreate my table where actually the data will be inserted. That is basically create or replace table video demo. Okay, table video demo successfully created. And now here if I do select start from video demo, currently we will be having no data in it. Now what we will do, we will just start our this particular stored procedure, which will create one particular task. It will resume that, execute only once, and suspend the task. Okay, so here I am starting the code. Okay, here it is started. In a new window, I can basically query all the required stuff. Like here I can copy this particular task name, I can open a new window, I will use this particular database. If I do show task, here you will see along with our first task what we created, here one more child task is automatically created by our stored procedure. Okay, right? And now here I can paste this particular task name which our stored procedure dynamically created and query information schema to check the status. Obviously query ID we are getting null because when it is executing, first time execution will happen after 1 minute. That's why we have given a sleep time of 90 seconds, because 60 seconds it will take just before execution, and after that it will be executing, updating information schema. So for that we are giving more 30 seconds, and after 90 seconds we are starting our poll in information schema. Okay, So let's see whether any data came or not. Not yet. Any data has not come. Okay. So just wait for a couple of seconds. When we'll see for the first time the data is inserted, automatically this particular task, multi-thread child, should be suspended also. It should not execute one more time. Okay. So here I will execute show task again. Currently here you can see our multi-thread child task is started. Okay. It is basically in execution phase. Query ID is still null. Okay. That means the task even has not executed at least once. So here you can see we are getting a query ID, right? That means the task is executed. Even if I do select start from video demo, here we are having a particular row which was not present earlier. So what should happen? Automatically this particular stored procedure should stop execution, and see, it is successful. That is, before this particular task is executing next time, it is stopping that. Okay, that's the beauty of this particular stored procedure what I just now discussed. So if I do select star, we are having only one data, and if I do show task, here you will see that this particular task which our stored procedure automatically created is now in suspended state. That's how this particular stored procedure is dynamically creating a task, executing only once and then terminating that, which is required for this particular parent task. Okay, now you can dynamically create as many child tasks as you want, execute them parallelly under the parent task. Just you have to set the dependency that all the child tasks should start execution once parent task is done. Okay, and how to set up the dependency, that also I have discussed. Okay, so that's what we are going to use in our next video. Even this particular query is helpful for many debugging purpose also. Like here, if I do select start from table information schema dot task history, here you will see that if sometime task thrown error or not, like here error code column is there, right? So here in the error message you can see, like here some error message earlier when I was executing some task, I got error like statement reached its statement or warehouse timeout 3000 second and was not cancelled, etc. Okay, so these are something which you can obviously explore. Just have some dry run in this particular stored procedure, try to understand what each step is doing. I hope you will really find it insightful, and we are going to use the same stored procedure in our upcoming video for parallel execution of multiple stored procedures. Okay, so if you find this video helpful, then please like, share and comment. Subscribe our channel if you have not subscribed till now, and don't forget to press the bell icon to get the notification of our latest videos. Thank you.